Giggle.
Hello everyone, I am Teacher Crocodile.
I'm Teacher Sloth.
Today we are going to discuss the 2021 Learning Lab Teacher Training course. This course will be delivered over 2 days, but it's fine if you want to watch all the content in one day. Let's take a look at the first course. This covers the basic introduction to the Learning Lab. This includes the application of materials in the various extension courses. For the second course, we will discuss programming. In the programming course, we will use the 1269 set and the microbit unit with the latest 1206 Web AI interface. We will go through a simple example of how to write a program and how to use Web AI. For the second day, we will look at World GreenMac. In the World GreenMac section, we will introduce some basic principles, such as connecting devices together. And in addition to the original contest, we will add a new contest using set 1205. This little box will show how to complete some challenges. Finally, in the fourth section, we will share some of our experiences and look at CQ certification. With regard to CQ certification, we hope that you can all work together to promote this in your own country. That way, everyone can build together and promote learning through Play with Giggle. Let's get started! First is the Learning Lab Basic Operations. Hey, Teacher Sloth, do you know what the most important thing in Learning Lab is?
What is it?
In Learning Lab, we often use basic designs to make building easier. For example, children can learn many things from a simple shape, like this flower. What's important is the STEAM foundation. STEAM focuses on hands-on experience. Basic scientific principles are found in textbooks where children can read and learn. But through hands-on assembly, they are faced with real-world learning and a concrete form. The hands-on approach also enables them to think about ways that a model can be modified or where it could be used or found in real life. Put simply, Learning Lab is designed to arouse children's curiosity. The building projects and games encourage them to learn more. So in each course, in addition to making models, the most important thing is that children get to practice the scientific principles through playing games. After some practice, they will really understand the scientific principles. Next, before we make the model or enter the courses, let's get to know some important Giggle components. Teacher Sloth, what do you think of all these components? Do you think we have a lot of parts?
Yes, lots. More than 500.
Wow, there are so many kinds. How can we simplify this situation to help children understand and recognize them?
Could we use categories?
That's right, we divided the components into 5 categories. The 5 categories are frames, rods, axles, gears, and pegs. Using categories make it easier for children to understand, especially when it comes to understanding the uses of components and when searching for them. Let's take a closer look at the 5 categories. We have frames, rods, axles, gears, and pegs. So the first one is frames. How can we classify a frame? The shape of a frame is like this, like a rectangle. The size of the frame is defined by the number of holes it has. Each hole is 8 mm in diameter, but with the plastic either side, it becomes 10 mm. There are 5 grids on this side, which is 50 mm. This side is 10 cm, this one is 15 cm. So if you combine these two frames, 10 plus 5 equals 15. They are the same length. Frames are very strong relative to other parts. Therefore, it is usually used as the base of a chassis, so it can support the rest of the model. In addition to forming the main structure, frames can be combined to extend larger structures. For example, when making tall towers, with 2 frames like these, it is easy to put them together like this, by stacking the frames up. However, this kind of structure may not be steady. But if the sizes and distances are well planned, all tall towers can be made stronger by supporting the structure with vertical staggering. If we want to build taller models, building the main structure this way is more stable. When disassembling the parts, try not to pull two frames apart just by pulling on them. It is easy enough for adults to do this, but we want to set the example for children and they may get injured. So show them this technique where you lightly shake the frame first before disassembling the parts. Gently shaking the parts loosens them just enough to create a small gap. Once you see the gap appear, you can use the packet remover by inserting the end and prying them apart carefully. If it's like this, where the assembly is tight, we can gently shake it to create a gap and then separate the pieces. This way is safer and the parts are less likely to become damaged. Children need to learn how to use components and tools safely during assembly and disassembly. So that was frames and how they work. The second category is rods. There are different types of rod component. They can be divided into two types. First, take a look at the appearance. What is the difference between these two? Looking at the side, one has many holes evenly spaced, but the other has either odd or even holes. This kind with all holes in the same side is called a number X hole rod, where X is the number of holes. For example, this is a number 3 hole rod, or just 3 hole rod for short. This is a 5 hole rod. This is an 11 hole rod. When the rods are paired with a frame, it is easy to do certain calculations and combinations. The size of the rods are the same, so to make it easier to tell them apart, the spit here extends, making it a little bit longer. We call it a 3-hole dual rod. This one has two parts, a main body and an extension. In Chinese, we call it super because it is so useful. This regular one can only combine two sides, but the special one can use all 6 sides, making it a super 3-hole dual rod. Similarly, this one is a 5-hole dual rod. This one is a 15-hole dual rod. These long rods can make a structure more stable and be used to add robust extensions, so they make modification easier. Next is the third category, axles. Children often get confused with axles. Let's look at the appearance first. For now, don't worry about its length. Take a look at overall appearance. You'll see that it's smooth. We call this the first type. This one won't get stuck. Here, let's try a gear to see how it works. When combined with other components, you can put it here and push it into the end, or even push it out. This is the first type of axle. The second type is this one. You can probably see this little ring at one end. Children might accidentally put the second type in the wrong way around. For example, when assembling, it goes smoothly when put in this way, but when it reaches the position, it gets stuck and there's no way to take it out. Or if a child installs in this way, they can't put it in because it is going in the wrong direction. So we usually use one of these two types of axle, type 1 and type 2. There is third type, but it is less common, only found in small number of sets. Here is the type 3 axle, but it is rarely used and only found in small number of sets, so we won't introduce it here. What are some common issues when children use axles? One problem may be that they cannot gauge how long an axle is. If there are no rulers around, we can actually use rods to do calculations. For example, here there are 1, 2, 3, 4, 5, 6, and 7 holes. So we know that the length of this axle is 70 mm. Similarly, this axle has 3 holes, so it is 30 mm long. Axles are usually used with gears and wheels, but those we will address in more detail later. For now, let's go on to the fourth category, gears. This is the most common kind of gear. Gears come in various sizes, but the most common are 20T, 40T, and 60T, where T stands for the number of teeth. So the gears above have a ratio of 1 to 2 to 3. Gears are mostly used like this, where one is external or stands up, and the other turns vertically, like a crown gear. These two methods are commonly used in addition to gears. There are pulleys. If we add a rubber band, it can be used as a pulley belt. It is a useful tool for power or transmission of movement. This one here is a sprocket, sometimes called a 10T chain gear. It has relatively large teeth, so it can be used with a chain. Because it has large teeth, it can be incorporated into a ratchet mechanism or used to trigger other components. In addition to these driving gears, we also have various types of tire. The most commonly used are these ones. These are good to use as wheels on a car because it is one of the heavier duty components. The weight means it can also be used as a counterweight. Ordinary gears are used installed off the frames. Install it like this, because if you make the fit too tight, it won't be able to spin freely. To loosen and remove them, use a peg remover. To make a small gap, when it is installed, you can put it away to keep it from touching the frame. Then it can turn. As we mentioned, there is a third type of axle. The third type axle is used here. Don't let the gear get too close to the frame. Because the Type 3 axle may be difficult to use in some situations, we often just use a Type 2 axle and then make a small gap with the peg remover. If we use the flattered end of the peg remover, the gap is just right and it spins smoothly. Gears and pulleys can be assembled like this. Again, if we use a pulley like this, it can rotate because of the friction. Just use the peg remover. Push it back a little bit, and then it spins smoothly. So that was the fourth category, gears and wheels. The last category is pegs. Why do we call it pegs? Because the component is small, it looks like a peg and it holds things together. Let's spot some component differences. You can see that these only differ in size. This is a short peg. This is a long peg. This is an axle connector. These three are the most commonly types. Let's look at these two first. The first difference between the two is how they combine components. For example, if we use this long peg, it is sturdy and fits tightly. It grips well and does not wobble if the model moves. It is usually used as to join frames or beams securely. However, if this blue axle connector is loose enough to spin and turn, so for stability, use a long peg. But for movement and spin, like you would find in a linkage mechanism, we have to use an axle connector. This lets the device move. Because of this, the blue axle connectors are easier to remove. It can be pulled out with just fingertip strength. From the back, you can just give it a little push with your thumb. It is easily removed. Remember, blues are the easy to remove axle connectors. Long pegs will remain in the model. Even after you pull two joint rods apart, it is difficult to remove with just your fingers. This is why all the sets come with a peg remover. The peg remover has two ends that are different. One is thinner, so you can put it in like this. After putting it in, don't push upwards. We need to turn it to the correct position first, and then turn it into the middle. And then press down after it is turned towards the middle. It's a good idea to keep your thumb here so components don't fly across the room. So you take it apart like this. This is the difference between the two pegs. Next, let's look at these two pegs. One is black, the other is red. The red one is long and the black one is short. Functionally, they are the same. The only difference is that when they are combined in the same position, we can make a greater variety of combinations. For example, when we assemble these rods, like this, we can put the peg in the middle hole of the first rod. Here, we'll do the same thing, and put the pegs in the middle. Load it up. Install it. In appearance, there is almost no difference between the two. But if we want to add another peg in the same position to connect our rod, we'll just put the peg in here and continue building. Here's the same thing again. Add another rod, and when it is turned in the same position, the long peg appears like this, with a slit. You see the short peg can connect perfectly without leaving a gap. So, if you want to connect to the same place on the model, we have to use a short peg. Because if we use a long peg, it will leave a gap. Okay, so this is how the pegs are used. Now, we've classified the parts. Let's start the first basic course, simple machines. Teacher Sloth, do you know what a simple machine is?
Sure, I know. Time-saving, labor-saving, and easy to operate.
That's right. Simple machines always have these three characteristics. When we discuss simple machines, we look at the most fundamental scientific principles, things such as gears, levers, inclined planes, and so on. These are covered in depth by the class materials. By using these principles and building models, children learn what the simple machines are. Teacher Sloth, what did I have two simple machines that are connected?
That's a compound machine.
That's right, it is a compound machine. In the course, if children continue learning, they can practice combining the principles. They will be able to repeat experiments and test the principles for themselves. When there is a problem, they can solve it easily. Next, we'll make the first model. There's a component list for each model. This helps children prepare the parts they need. The assembly steps are provided and children can follow them one at a time. First, let's make a catapult. In the building process, you can change the design or structure. Later, children can hold a contest and record a video of their project working. Remember, don't immediately disassemble or dispose of the model when it's complete, because we still need to run the experiments. Experiments are the most important part of Learning Lab. Teacher Sloth will show you how to build a model.
First, prepare a 15-hole rod as lever. Next, make a platform to hold projectiles. For this, we use the banded rod, which is a 90-degree 3-hole arch rod. Connect the 4 banded rods to form a circle. It should look like this when it is complete. We put the long peg in the hole at the bottom of the long rod. Then after we put on the long peg, we can connect the 15-hole rod a circle together. Now the simple lever is done. Next, we have to make a frame for the catapult to ensure that the lever is stable. During operation, we'll put long pegs on both sides. After putting the long pegs here, take a 60D gear and install it here. This increases the stability of the lever so that the model will not be break or fall apart when it's used. For now, this next part of the lever is done. Let's start the base. For the base part, you can use the large jumbo base grid, or you can use a small 8x12 base grid, or even a frame. These three can all serve as a base. Now, let's build the main structure. First, add two 5x10 frames. I suggest that you put a 3-hole dual rod on the bottom and add a long peg. Then you can connect the first frame to the second frame. Like this. This will increase stability. Let's also add a long peg to the bottom of the 3-hole dual rod, which will connect with the rubber band. Here's one I prepared ahead of time. See the hole in the bottom of the 3-hole dual rod? Put a long peg in there. This finishes the structure of the catapult, which can now be set anywhere on the case grid. After the position has been set, we need to combine this lever with the main structure. Here we will position the lever where we need it. Let's see if we can fit it through this hole. The second hole counting from the top. After we align the holes, we can pass it through and make a connection. So now you can see that the catapult structure is really quite basic. If you find this axle shaking when you use it, on the right hand side, we can install a sprocket or gear to secure it. I use a sprocket here. This reduces vibration in the model that makes shake it apart after several use. Next, it is the most important part. We need to add a rubber band for elastic power. Get a rubber band and pass it through the bottom hole of the lever here. After a rubber band has gone through, then push it all the way out. Keep some on either side. Loop it over the long peg you inserted down here on the 3-hole dual rod, like this. The appearance of the catapult end merges. Now let's add a special function. You can see there are many teeth on the sprocket. We can use that to make trigger function for the catapult. Here I use a 15-hole rod. Then put a simple axle connector to connect it to the frame. As long as the long rod can mesh with the sprocket, it will lock when the sprocket rotates one way. You can turn it by hands like this, and then use the 15-hole rod to mesh with the sprocket. After this, the two machines are connected, and when you tap the 15-hole rod, the catapult fires. The catapult is done.
Now let's have a stone throwing contest. Before beginning the contest, be sure to explain that the contest is important. Otherwise, children may not realize the importance of it because they had so much fun making the model. The competition pushes children to achieve a goal, and later they will be able to modify their models. In the process of modifying the model, the children will learn the scientific principles and understand the adjustment factors and the results. If children take longer to build a model, then provide an easier goal. If the group are more capable, then we can assign a more complex or challenging task to fit the situation. It looks like you're all doing well today, so let's adjust the difficulty goal higher by say 100 times. So what are the goals here? First, make the model. I guess you all made it, right? Teacher Staff, have you finished the model?
Yes.
Next, place a container with an opening about 30 by 15 cm at a distance of 2 meters. Remember, you can use components to measure the size if you like. The large jumbo-based grid here is 300 mm long. You can find a hole bigger than that. Or you can find other items around you, measure the target. Videos should only be 1 minute. So be ready with your phone to start recording. 1 minute is the time limit you have to achieve the goal. Videos should not have any post-production, editing, or speed adjustment. Please follow the rules. As long as we score 5 goals in 1 minute, we complete the challenge. So now, we will set up the area, then we start the challenge. Ready?
Go! Let me try. Hey, why doesn't it work for me? What can I do?
If you find that the ball doesn't fly smoothly, we have to check each part of the model in turn. And if everything works fine, then let's modify the structure a bit. Because we want to throw this far, we must increase the elastic power, so you can move the lever to a new position so it has a greater draw. Or you can move this part slightly to change the parabola of the stone. Like this, the parabola is at one angle and it may not launch the way we want. So during the activity, you can modify your creation to achieve your goal. I hope you've all been following along with the video. Now let's take a closer look at what we've just been doing. As we often say, the secret is in the details. Teacher Sloth, how do you do?
No,
Do you know why?
because I wasn't able to adjust my model properly.
Ah, I see. When children make models, they also tend to have problems with that. I just did it exactly the same as the teacher, as the book showed. So why didn't my model work well? Let's think about it. When making any model or device, we also need to consider friction and elasticity. For example, after burning a new shots, the rubber band might become loose, so we can replace it with a new band. Or there are other factors like pressure, gravity, or buoyancy, and these can all influence the model. Sometimes it's hard to get things working. There may also be other problems. But this is the best opportunity to coach children on problem solving. What's next? We can use a few new models to demonstrate how to assemble and fine-tune devices, and even share some tips for the games. Take it easy. The next 2 models won't be recorded. We'll do them just for fun. Let's get started. This one is sloping slide, which are multi-layer tracks. It looks easy to make this track model, right? But if you want it to work well, it takes some skills. Teacher Sloth will demonstrate the assembly process for us.
Let's build it. First, make the tracks. The tracks can be made with 15-hole dual rods. We only need 15-hole dual rods and a 3-hole rod. Connect them together like this and it's done. Easy. Next, add 2 long pegs to it. The purpose of the pegs is to make sure that it can be combined with the main structure. After we assemble the track, we must make it a bit longer than the second track. Because I want this one to be a little longer, I'll use the 2 15-hole dual rods. like this. For this 15-hole rod, I want to end to be curved. So I have to add a bended rod to the end. In this way, as the ball falls, it slides down the track. So now we have a little problem. How can we combine these two together? We can try putting a 3-hole rod here. If we put a short pad on each end of the 3-hole rod, then we only need to put the rod on the bottom slide to make connection more stable. This way, the track will not tilt during use. Connect it like this. Now it's stable. Finally, make a connection between the tracks and the structure. Put a long peg on each side of the track. Like this. Now our 2 track parts are complete. This is the ascending track. The ball will roll down from here and then it will roll down to the longer track below. Let's continue building this main structure. Now let's start making the structure. First, make a base with this small 8x12 base grid. Of course, it is okay if you want to use a large jumbo base grid. For this structure, we are going to make 2 layer tracks, so we use the 5x15 frame. And then choose where to put in on the grid. Add another long frame nearby, so there are 2 frames now. Then connect the tracks. After selecting the location, we can attach the track to the structure. Take the tracks. Place the upper layer here in a higher position, like this. After placing the upper track, we need to think about where to place the lower track. We can simulate like this. A slope like this is perfect. Now insert the peg into the hole on the structure. Like this. In this way, the ball can roll all the way down from here to here. Next, let's make the right side of structure and assemble it on the grid. The structure on the right is also a simple 5x15 frame. Remember to align the holes on the other side. This will mark the device symmetrical and stable. Next, assemble the other side. After connecting all the parts, we have to confirm it is stable. This finishes the basic model. Then you can try to modify the model or improve the stability by adding some materials to the base. What about the extend part? Teacher Crocodile is here to help.
Wow, Teacher Sloth, you finished the model so quickly.
Sure.
Let's try it first to see if the marbles roll down successfully. Oh, it's a success. When assembling models, particularly one like this, there is usually something we can do to make improvements. For example, when Teacher Sloth was assembling this part, he found it difficult to put the peg in. We recommend another component to help, like this long rod. We know that the width of the middle of this track is 1 cm, so put the rod in, align it and pinch it. That makes it firm and stable. You can also use other parts in the middle. And then apply the force, it's up to you. This can make it stronger and more symmetrical.
It took me a long time to put it all together.
Now the track moves up and down. If we want to make adjustment to the device, the angle or position of the track is where we make the first changes. We can also take out this peg. When people make the track, they tend to fix the track onto the frame at the front and back. But in fact, when we make the slope, we should only use one point at first. For example, in this position, fix it like this. What about another angle? Let's set it on the second or third hole from the top. Put it this way. Put it on this hole. On the other side, fix it the same way. In fact, it's okay to connect on just one side. Connecting to the other side is for stability. After putting it up, just press the track down. Because of the position of this point, the track can maintain the same angle every time. Even if someone suddenly shakes the model, the ball won't fall off. This method can be used anywhere in the model. So, for a simple model like this, adults may find it easy to build. But for children, it may be not that easy. So we are able to adjust the difficulty according to their ability. For example, you could get them to just extend the track, or combine it with some quick games. These all depend on the learning experience. On this track, we can use these long rods to play a bowling game. Use the long rods to make a rack of bowling pins. Go! Wow! Great! I think playing this kind of game is easy for adults. Children will learn how to slowly adjust trajectories by playing this game. In the beginning, use simple, straight lines. But what comes after that? We can ask the children to make a 3-level track or make the ball turn. Children love personalizing and extending projects. So, do you understand how to make adjustments to this model? If the answer is yes, then let's move on to the next one. The previous model was a basic track. Now, let's work on this gear set and discuss ratios. This one is a 27:1 multiplier. Where do we get 27 from? Well, here this gear has 60 teeth and the smaller one has 20. The ratio is 1:3. We often write as 1:3. Here, this pattern repeats 3 times. So 3 times 3 times 3 equals 27. If you were to change to another gear halfway through, you would change the ratio, making it faster or slower. Let's ask Teacher Sloth to make this a 27:1 ratio. After the model is done, we can talk about how he did it. Teacher Sloth, take it away.
Sure. To start with, we'll use a small 8x12 base grid as the foundation. Now let's look at the structure of the gear set. Pick 2 5x10 frames. In the middle, it needs a connector of sorts. I'll use a dual road. Put a long peg on the button. Then can combine the 2 frames. Like this. Now choose a place to put it. That's the structure done. Here comes the important part. We want to make it a 27:1 ratio. So let's choose an axle with sufficient length. This axle should be a little longer than the distance between 2 frames. The axle must not be shorter than the structure. I have a 100 mm axle here. This part is the gear transmission. After putting the axle on the frame, I can set the position of the axle on this side. Then I can put the 60T gear on this side. Like this. Then I have to think for a minute. How do I keep the gears running? Because 27 is the same as 3 times 3 times 3. I'll have to put a red gear under the yellow gear. So if I line up the holes correctly, that'll make sure the gears can mash and rotate. Now I have to slide an axle through the red gear. Let's have a look at what's happening here. Don't rush to push this axle all the way through the red gear. We'll need to extend it later. Let's recap. First, we put the 60T gear here on the inside. Then after it passes through the 60T gear, the red gear slides on here on the outside. Did you spot it? Let's give it 3 times the power. The red gear drives the yellow gear. Because the yellow gear is on the same axle as the red gear, so when the red gear rotates, the yellow gear will also rotate. Now we have 3 times the power. Let's carry on and make it 9, then 27 times. So to do a 9x gain, take out another red gear. First check where it can match with the yellow gear on the inside, probably somewhere here. After confirming the position, we can take out another axle. Thread it through the correct hole in the frame like this and add the red gear. Just be sure to pass the axle through both frames, because we need to make sure that it can transmit power. Next, just here, we'll put another yellow gear, because our goal was 27 to 1. Once again, extend this side to make it 27. On this side, make sure the yellow gear aligns with the other parts. Then pass the axle through the yellow gear. Remember that the position of these gears must be adjusted to ensure that each gear is smashed correctly. Remember not to install the gear too close to the frame when you're putting it on, because if it's too close, it will rub on the frame. After positioning the gear correctly, then we can move on to the last step. We'll do an extension up on this side. We need to extend it up, because obviously there is no space below. To do this, we can use this red gear. Confirm that the connecting point of the red gear and the yellow gear. And then use the axle to pass through. Like this. Now, let's just make a simple addition by putting a yellow gear on that side, then putting another yellow gear on this side. It's nearly finished, but we need to add some handles. Of course, we can turn the gear directly by hand, but it's not very convenient. So I suggest that once you're done with the main model, use a small hole on the yellow gear to install an axle. Take the shortest 30mm axle and install it as a handle. Now it spins more easily. You can also add an axle to another side. The gear set is now complete.
Wow, Teacher Sloth, you're so fast.
Really?
This particular model may be complicated for children, especially finding a place for the gear smash. In part, this is because the axle only goes in a particular direction. When children are building, they might also press the gears too close to the frame. That's why, in the component introduction, we provide a solution for this. We can use fingertip string to just push it away a little bit. Or use a peg remover to measure the right distance. Insert the peg remover here and then press it down gently. The peg remover leaves just the right space for smooth rotation. Now let's look at how it works and changes we can make. Children often look at this and think, done. But teachers have to think differently. For example, to complete a course, teachers must know that the children are able to use the model and see how to use it in the real world. Children often fall into a trap of making something that matches the book and thinking that is all there is to it, and now it is complete. But this is a learning opportunity that is overlooked. To guide children in learning, it helps to have tiered goals. For example, here are 4 steps. Let's take a look. The first one is to set a clear and achievable goal. What do we hope children will do? It's like asking, what games do we want children to play? Next, we need to plan ahead. What materials or action do children need to prepare to achieve their goal? Next is construction. After we have drawn up the plans, children can complete it by hand themselves. Finally, the results must be evaluated. Did they achieve the goal? Using the models, lead the children to follow through on these additional steps and reach a higher level. For this model, what kind of goals can we set? For example, I want Teacher Sloth to run this model into a crane. Teacher Sloth, if I want to modify into a crane, what should we change first?
Change its structure.
Some cranes are relatively tall, some are relatively short. Some are high up on top of buildings, others are on the back of a truck. So we can change the structure, but we can start changing the appearance. If we want to change its appearance, what parts do we need to prepare? This is where we need to draw up a plan. What's needed? Then next step is to make the modification. According to the child's preferences, this is the course goal we are aiming for today. We can also match different things. For example, we know that there are many different Giga components. But in addition to the basic components, there are wind power, water power, solar energy, and saltwater power generation. These parts can make the models more interesting. Besides understanding physics and machines, we can add green energy concept to learn more and have more fun. Take a look here. If I use this gear set and add a windmill, what will it become? Teacher Sloth, what do you think the combination of these two will become?
A wind reel?
Right on! Okay, Teacher Sloth, since you got that one so easily, how about this challenge? Your second assignment is make a wind reel. Later, we'll use this 27:1 ratio gear set, add the windmill blades, and create a new model. We want this new model to function correctly, so we'll follow the instruction on the slides. For example, using a 27:1 gear set and adding windmill blades. Now, I can place an electric fan 1 meter away and see if it turns the blades. If you are in a place where the wind is strong, you don't need to use the electric fan. Recording a 1-minute video. Remember, no editing or speed adjustments. It must be complete within a minute. So, what's the goal here? After finishing the wind reel model, put it on the table. We'll also need a PET bottle that contains at least 200 cc's of water. Use a wind reel to lift the bottle from the ground to at least 100 mm, that is 10 cm. Now, take a look. Observe carefully. If your wind reel is well constructed, it can easily lift the water bottle when the wind blows. But if you put it in the wrong place or made a mistake, the water bottle might not move, even the wind reel turns. Okay, let's build this together. In the modified version, it can maintain its original appearance. However, because the model may be blown away by the wind, we must use a larger base grid to make it stable. We have to make a basic windmill structure first. Here, prepare 3 blades and these parts. This part is used to make the windmill. One mistake children sometimes make is that they might push the rod in too much. If you push the rod in too far, it will get stuck inside and can't be pulled out. If it happens, we can open the blade from the side. Like this. And after it is opened, we can push the rod out. So if the rod is stuck inside, we can open this blade. Because the length of the blades and rods should be the same, we can fix it to the second hole of the rod. Don't use red pegs to fix it. It will be harder to remove red pegs. We must use the short button fixer. Put it in that hole, so that it is fixed securely. Install all these rods on the blades. It's okay if you want to make 6 blades. It's up to you. Remember to use the same direction for all 3 blades and install it like this. That's the wind structure done. Now, how can we fit it on the reel? It should be in the position where it can rotate smoothly. It can easily roll up the rope with the water bottle. However, if I put it in this position, we need to use the longer axle here. Let's replace it with a longer axle. Also, the fan blades are pretty long, so we need to raise up the structure a little bit. And replace this with a longer 15 cm axle. Now we can replace this. We don't need the handle anymore, so we can remove that. Then add a gear. It is not necessary, but it can help reduce slippage. Install the blades on the model. Now we have the basic shape. Try and spin it. It spins smoothly. As long as it can rotate smoothly, it will also turn smoothly when reeling. Now let's elevate it and add a base. I want a quick and simple solution, so I'll use an 8x12 base grid. Why? To avoid the fan blades knocking on the table. Next, move the model to the edge. To elevate it, we will add this frame, which will lengthen the structure and make it higher than the fan blades. So, they don't hit the table. Add pegs under the frames, which will fix everything to the jumbo base grid. Now, the jumbo base grid can be moved slightly toward the center of the table. Find a good place for it, so it can rotate smoothly when it reels. It's finished! Once it's done, I need to check that it can wind up rope from here. Because the axle is kind of short, it may be inconvenient when we are reeling the line in. We can also add a red gear here to prevent the rope from falling. Now we can do some experiments. If students have their own ideas and want to make their own modification, that's fine. Now we can tie the rope on. The gap between the 2 gears here means that the rope can reel in a stable manner. Let's wind it directly into this gap. If we put the knot here, it can be released more easily later. Just tie it here. When it starts reeling, it won't wind perfectly onto the axle. We can fix this by doing 1 or 2 turns by hand first. This will happen later when the wind is powering it. Over here, there's a water bottle on the ground, and place a 10-hole frame nearby. Make it lift up the bottle more than 10 cm. We just tie the rope up. Remember to keep the edge of the jumbo base grid and the edge of the table in the same vertical line. Now, turn on the fan to see what happens. It can lift the bottle. Teacher's lost. The bottle is going up. The goal is to lift up to 10 cm in 1 minute. In the place where you are working, if it is too windy, or if there are other environmental factors. You can add some heavy objects on the base grid. This will make it more stable. We can see the bottle is now gradually lifting up. Now it's over the top of the frame. Great, we did it. I hope you all successfully complete the second model. When we are making or modifying models, we must discuss that good work looks like with the children. One factor is stability. For example, in this experiment, every gear rotation should be smooth. When all the gears mesh correctly, the device functions smoothly. We must make sure the basic function is working. But in addition to working, we should also aim higher by making improvements. This is essential for stability. Next is the strength part. It means that the whole structure of the model is steady. For example, if the wind is too strong, the model will fall over. Or if the pieces are not assembled properly, it may come apart, so we use a large jumbo base grid. If you use a small base grid, the whole model may blow away. This means the model is not strong enough. Next is functionality. Its functionality is its goal. For example, lifting up a water bottle, if we want to measure its functionality, we can say that the more weight it lifts, the better it functions. If we want to improve the functionality, we may need to change the structure, the gear ratio, or the arrangement of the fan blades. These factors influence functionality. We hope that children can make adjustments to improve or adapt the functionality. Next is practicality, where it can be used. We can think about this question. Are there any other use it could have while it's operating? The last part is aesthetic. For example, when I build, I always try to consider symmetry, or color distribution or balance in the work. This makes it more harmonious. The rest is really up to the children. Allow them to leeway to play with their devices. Some children's designs are cool. Some children like simplicity. Others like complexity. The model can be adjusted according to their personal preference. If a work can meet all the basic conditions here, it is perfect. But we still hope children can enjoy the process of development. Making a model and developing it are important concepts. In our Learning Lab courses, we provide introductions to the models in the manual and all the assembly steps. If the lessons are completed fully, it will be possible to learn a lot with the children. But remember, in addition to the models in the manual, we can always make extensions. For example, this new set is 7452. It is an intelligently controlled programmable mechanical ball. The difference between this set and the Learning Lab is that its materials adopt a specific shape. Because of this limitation, the error rate in assembly is reduced. The same four-stage application found here is also in that manual. For example, let's always start with guidance, in which you can tell a story. or bring up certain relevant scientific principles. Then, through the assembly and explanation, children gradually acquire knowledge and experience about the world of programming. Children can then enjoy playing with the set. The programming here is simple. It only introduces the concepts of timing. With the concept of sequences, children can easily enter the intermediate programming courses. So later, we will ask you to make this bold project. When children will learn the basic concepts relating to programming, after making a ball, please try it out. Playing with it will build the foundation you need to proceed smoothly to the programming course. We'll share a video with you later so you can see the assembly steps and watch the unboxing on the internet. Let's see the video. Hello everyone, I'm Teacher Raccoon. Today, I'm going to unpack the set with you. 7452 Robotic Smart Machines Super Sphere. This set is inspired by the idea of spherical robots. Spherical robots have many advantages. The first one is that spheres are a naturally strong shape. They are less easily damaged. The second advantage is that they can easily move over different terrain. Both land and sea are a piece of cake for them. They can even roll in outer space. Some of the most famous spherical robots are Vero's robot and BB-8 in the movie Star Wars. Some robots have highly developed technology like camera sensors on them. For example, they can track, record, auto-follow, align, or even be used in sport events. There are many ways that spherical robots can move, but the one thing they all have in common is that they manipulate their center of gravity. The movement design can generally be divided into two types, depending on whether it is powered by the sphere. The way initial movement is created is often different to the way movement is maintained. Every point of the ball will touch the ground. If you put a remote control car into the sphere, controlling the car will affect the movement of the sphere. The disadvantages of this control type is that the remote control device is often unstable inside the ball and it cannot be accurately controlled. It's like putting a hamster in the ball. This hamster can't decide where it wants to go, so it may end up running too far in one direction. So here, we can add a gravity control system. Controlling of the center of gravity makes the sphere much more stable. The Super Sphere and BB-8 both use this kind of design. The other type is a combination of dynamic structure and center of gravity. The motor is usually fixed on a horizontal axle. The two endpoints of the horizontal axle do not touch the ground immediately when moving. The power transmission method can be divided into two stages. The first governs the motor that moves either forward or backward. This controls the angular momentum, which also governs the steering. The second type divides the sphere into two hemispheres. Each part is controlled by an individual motor. The difference in positions between the two parts is called the slip ratio and helps the ball to turn. This super sphere belongs to the first control type because it steers by changing its angular momentum. Let's take a quick look at the box. This set has 7 different models to explore and is suitable for children 8 years and older. There are 182 components and 8 fun experiments. To get to the official Giga website, you can scan this QR code in the lower right corner. Now, if you see this pattern on the box, you'll know that you need a tablet or smartphone to run the app and write programs to control the robot. Let's take a look at the components. These are all the components here. It mainly uses a geometric system. Those pieces are here. The characteristic of the geometric system is that the metal slide is hollowed out. This design is beautiful but lightweight. When we are assembling the model like this, we can reach our fingers in and assemble from the inside. It is convenient for us to hold both sides and connect the joints. You see, Just like this, the gigogymnastic system has a smooth surface. It has these curves because otherwise it wouldn't be a sphere. So every side must be smooth and even. Take a look again. This geometric piece has an eye. There's an eye sticker here. Because 2 of the 7 models are bionic. The horseshoe crab and the penguin. When we make a bionic model, we will usually use the geometric piece with the eye sticker to make them look more lifelike and vivid. The next special part I want to show you is the planetary gearbox, which is found in many sets. The other special part is right here. This is the sound sensor. It is like a human ear that can receive sound. It can also be used to identify sounds. There's one unique component in this set. It's quite heavy, so be careful when you take it out. This is the weight, and it is used together with the weight housing. As I mentioned earlier, spherical robots can change direction by rotating a heavy object. By changing the position of this weight, a spherical robot can generate angular momentum. That's how this robot moves forward, backwards, and turns. The next part we are going to look at is also widely used in many sets. This is the Bluetooth receiver. It can receive a Bluetooth signal and then convert it into an electrical signal to give instructions to the motor. For shipping safely, Gigo does not provide batteries with the set, so make sure you plan ahead and have the 3 AA batteries ready. Let's have a look at the app. I'll show you how to download it and use it. You can find the app in either the Google Play Store or iOS App Store. Search for Gigo Super Sphere. Gigo Super Sphere. This is the app you'll need. If you haven't downloaded yet, the download button will show. We have downloaded it already, so we'll just open it. Don't forget that because the app in this set uses Bluetooth, the receiver box needs it to function correctly. So Bluetooth settings on your tablet or phone need to be turned on. In addition, we also recommend turning on the GPS. This will improve the connection. After opening the app, the first interface you see here is called Remote Control Mode. You can see that there are 2 sliders. These control the left and right motors. Before we can use this though, we need to pair and connect the Bluetooth devices to control the 2 motors. To do this, tap on the Bluetooth icon in the upper left corner of the app. Click. Now you can see a yellow light flashing on the off. The background color turns to blue. Did you see what happened? The motors work for a second or 2. This is the device checking the condition of the motors. Now we can remotely control these 2 motors. First, for the motor on the left, we use the left hand slider. This controls its direction of rotation. Now for the motor on the right, we use the right slider to control the direction. Next, in the upper right corner, there's a button here. What does this button do? Tap the button. After you tap the button, did you notice a change? Yes, the right slider changed from horizontal to vertical. This is because we have 7 models, and each model needs its own control method. So, according to the features of the model, we can switch remote control types. You can choose the horizontal or vertical slider to control your mode. Next, we'll take a look at the icon on the right. It looks like an arrow. Found it? Okay, tap it. This is programming mode. This is where you can write or edit programs. You can see there's already a list of programs, 24 altogether. Because there are 7 models in this set, the pre-configured programs are numbered 1 to 7. The 7 models have assigned demo programs in slots 1 to 7. For example, if you want to make the first model Super Sphere, let model use program 1. So let's open program 1. You can see there are 4 frame colors: gray, blue, green, and red. Can you see the clapping symbol to the left of these 4 frames? There's also a number in the lower right hand corner, 1, 2, 3, and 4. This shows the number of times we have to clap our hands. Using this, we can tell the device which program to run just by clapping our hands the right number of times. Suppose I clap twice, it'll run the blue program. Remember, the program relies on input from the sound sensor. Before we clap our hands, we have to press this triangular button first. The icon is an arrow facing right. Pressing this will run the program. Now, if I clap my hands twice, you see the program being executed as a little yellow frame around it. This one is the blue program, and it has a yellow frame highlight. If you want to stop the program, tap the triangular button again, and it becomes a square. Let's do it again. Now, let's do some programming. You'll be able to write your own program or jump to other pre-configured programs easily by using this folder icon. You can also return to programming mode. Programs 1 to 7 are all preset, as I mentioned earlier, but the program bank after 7 is empty. Open the program 9 so we can go through an example. See, it's all blank. Adding programs is easy. Tap the plus sign, then tap it again. Then you'll see 3 menus pop up. From left to right, these are motors, notes, and rest. The rest function is to add a pause to the program. First, we will write a motor program. After you select motor, you'll see a blue gear and red gear, and these represent the 2 motors. The control interval range is -4 to +4, where positive and negative represent the motor direction. You could also call them clockwise or counterclockwise. The number from 1 to 4 represents the power output. Here, we'll set the blue motor to turn clockwise at maximum power. Let's set the other motor to turn counterclockwise with maximum power. The bar here is running duration. For now, set it to 1 second and to activate when the hands clap once. When we clap twice, we can add another instruction. The program note is here. Do, re, mi, fa, sol, la, si, do. It's a standard musical scale. So if we want to play mi for 1.5 seconds, we tap the check mark here. Then we can add a rest in the middle to pause for 1 second. After that, we can play a second note. Let's make this one la, but a longer la sound. Let's say 5 seconds. Okay, we're nearly done. Pay close attention to the notes in the program. The sounds come from your smartphone or tablet, though you need to make sure your media volume is turned up. To see if it's running or not, you can clap your hands. While there's no sound. You didn't turn up the media volume on your device. Now, tap the right arrow. After you tap it, you'll be running correctly. Let's check that the device detects sounds correctly. Clap your hands once. Watch. The motors will spin for 1 second. Next, clap your hands twice. This triggers the music program. Children can also use this to make their own musical arrangements. If you want to stop, tap the square icon. If you think the program is good and you want to save it, tap the down arrow here, and it will ask you if you want to save the program. Tap it, and you'll get a message saying it was saved. If you don't like this program, that's fine too. Just hit the trash can icon. If there's a lot of programs and you want to delete them all, the trash can icon in the upper right corner will delete everything. If you click this icon next to the trash can, you will return to the previous save state. This was just an overview of some of the programming mode functions. If you want to return to remote control mode, it's very easy. Just tap the left arrow to return. Then you'll be asked, do you want to leave programming mode? Yes, take you back to remote control mode. So this has shown you some of the ways to use this app. Now we can prepare to build a model. Go! Here's the Gigo 7452 Robotic Smart Machine Super Sphere. If you like this video, please remember to hit like down below and remember to subscribe to the channel. I'm Teacher Raccoon and I look forward to seeing you again in the next video. Bye for now. Right, I hope you're back here and have seen the video and assemble your ball. Really, with this said, there are many things for you to explore. Following the course or manual, it is easy to find a direction to extend and explore. Some people like to change the appearance. Some prefer to think inside with how it works. Maybe you will make it faster or slower. Gigo building blocks present infinite possibilities for you to explore. We hope that after this simple course, you are able to understand some important facts about components and understand how the courses are structured and geared towards learning. Let's move on to the next course.